So let's talk about tokenization. So why tokenization exists, and why tokenization is one of the most important foundations in NLP, or natural language processing. It's turning human text into machine readable numbers. So why tokenization exists? Computers do not naturally understand words like "I love my dog." A computer only understands numbers. So before AI models like BERT can process language, text must be transformed into smaller units called tokens. Example sentence, "I love my dog." So the tokens becomes would looks like "I love my dog," and these tokens are converted into IDs like I for 1, love for 2, my is for 3, dog is for 4. So the core goal of this is a manual tokenization. Uh, I mean, the goal of what we did in the laboratory is the manual tokenization from scratch. We build lowercase conversion. We split the words. We have the vocabulary. We have the word to number mapping. So what is pre-trained tokenization, BERT or Hugging Face? We use the BERT tokenizer fast auto tokenizer. This is how professionals do in natural language processing. So let's dive into the manual tokenization. So let's say we have the sample sentences, "I love my dog" and "I love my cat." And we have the tokenized function, and it returns some tokens. So what it does is, let's say we have the text "I love my dog," and it turned it to the lowercase. So all the word or tokens becomes lowercase, and after that we split by the spaces, like I love my dog. And why we lowercase? Without lowercase, the big I will become equivalent to small I. So, and that creates duplicate vocabulary entries. So let's build the vocabulary. Let's say we have the sentence "I love my dog," the tokens we have "I love my dog," and so the vocabulary becomes I is equal to 1, love equal to 2, my is equal to 3, and dog is equivalent to 4. So the second sentence, "I love my cat," so the tokens "I love my cat." So new word is cat. So the final vocab, say I is equal to 1, love is equal to 2, my is 3, dog is 4, cat is 5. So the final output, so in the vocabulary index, I and its index 1, loves 2, my is 3, dog is 4, and cat is 5. So why this manual method matters? Its benefits: we learn text processing or text pre-processing, token splitting, indexing, vocabulary creation. So the problem is real world language is huge. Billions of words like running, runs, unbelievable, username, slang. Manual vocabulary becomes huge plus inefficient. Next is pre-trained BERT tokenizer. What is BERT? BERT is bidirectional encoder representations from transformers. It is a pre-trained language model trained on massive text datasets. Instead of making your own tokenizer, BERT already has approximately 30,000 plus learned tokens. So loading BERT tokenizer. We initial tokenizer. We use the codes or syntax codes of BERT tokenizer fast that from pre-trained, and instead of it is BERT based on keys. So what BERT based on keys mean? So BERT is an architecture based smaller standard versions, like BERT standard version like 12 layers, and a case means convert text into lowercase automatically. So we go to sentences. So tokenizer is, instead of it like have a padding of true, makes all sentence same length. Example without padding, like we have one the different lengths and hard for tensors. With padding, they have the same lengths. And what is truncation true? Cuts very long sentences if it's too large. Birthmarks length is 512 tokens. And what is return tensors and equivalent to PT? It returns PyTorch tensors. Next is special tokens added by BERT. What is this? BERT automatically adds LS or start of sentence, and SEP means end of sentence. Example, the sentence "I love my dog" becomes the first sentence of it having the tokens of CLS, and in the end of the sentence have the SEP. So why BERT was trained this way? Have the CLS, this for classification tasks, and SEP for separate sequences. Next is token IDs. Each token has predefined ID. Example, CLS is 101, SEP is 102. So we have in the token CLS, I love my dog, and SEP. It becomes 101, and in the end, our SEP is 102. So what is convert IDs to tokens? This reverses IDs into readable tokens. What is get vocab function does? This gives token ID mapping for entire BERT vocabulary. So the important here is word in the index codes have word index code in the laboratory was stored but not directly used. It exists so we can inspect vocab, search token IDs, understand BERT dictionary. Next is what is auto tokenizer. Why auto tokenizer? Instead of remembering BERT tokenizer, GPT2 tokenizer, Roberto tokenizer, we could use auto tokenizer from pre-trained, etc. So the advantage of it is it automatically loads the correct tokenizer for the model. So example, with initially tokenizer, but it will auto tokenizer that from pre-trained BERT base and case. Those syntax, and it could still loads BERT tokenizer fast. Why professionals prefer it? Prevents tokenizer model mismatch. Wrong tokenizer plus wrong model equals to poor results. So what is out of vocabulary or OOV word? The big natural language processing problem. What if a word is unseen? Example, hugging face. Maybe not an exact vocab. And that some of the words so rare and beautiful for us. So therefore, the model is not trained on it. So the BERT is solution. Subword tokenization. Example, the hugging face word could becomes hugging and double hashtag face. What is the meaning of double hashtag? Double hashtag means attach this to previous token, which means this token is belong to another token or previous token. So why this is powerful? Instead of storing millions of whole words, BERT stores reusable pieces like an, token, phrase, able, in. This reduces unknown words dramatically. Why subwords are better than whole words? So the manual philanthropist's words might be unknown, but BERT could be somewhat token like pill, double hashtag, and double hashtag double hashtag. So the model still understands components. So the real key lessons here: tokenizer plus model must match. Example, BERT tokenizer and BERT model, not GPT tokenizer and BERT model. Why each model expects specific token IDs, special tokens, tokenization rules. So this is final. So the raw text, the manual, the BERT. So the manual versus BERT is it have the lowercase? Yes, for the manual, and BERT for uncased. In the manual, the vocabulary is small, and in the BERT is massive pre-trained. What about the OOV handling, or the what we call out of vocabulary or unseen data? In manual, it is poor. and BERT and excellent in subwords. What about the special tokens? In manual, it doesn't have, but in BERT is yes. In real world use, in the manual is for educational, but BERT in production. So the final summary, the manual is tokens splitting, vocabulary, tokens IDs, but the BERT is pre-trained tokenization, having a CLS and CF, having a padding, truncation, subword tokenization, and OOV handling. So the concept is tokenization is a bridge between human language and machine learning. Without tokenization, AI cannot read text. So, and with tokenization, text becomes tensors, tensors become embeddings, and embeddings becomes understanding.